Okay, so circumference of 84 centimeters with a possible error of 0.05 centimeters. Okay, so that's the setup. And then we want to use differentials, part A, to estimate the maximum error in the calculated surface area. And then we also want to use differentials to estimate the error in the calculated volume. And then we want to find the relative error as well. Okay, so essentially what we have this circumference, right? And we think it's 84 centimeters, but we have a little bit of error. We could be smaller than that. Okay, and then we have that resulting sphere. Or alternatively, our possible error could give us a bigger circumference. And so then we would have a bigger sphere, and then of course a bigger surface area and a bigger volume. All right, so I have three spheres here. So we're saying that the possible error is 0.05 centimeters. So that difference in circumference, that could be the 0.05 of some way. Okay, so that would be considered a delta C or a DC. And that equals 0.05. And it can go both ways, right? It could also be on the inside. So DC delta C, that error is 0.05 plus or minus, okay? And then if that varies, we know the volume's going to change and we know the surface area is going to change, okay? So this is behaving like our independent variable. And then the volume, the surface area are the dependent variables. Okay, so part A, we want to find the maximum error in the surface area. And then we want to find something called the relative error, which I'll define in just a little bit. The relative error. Okay, so we have some formulas for our sphere. The surface area is given by the formula 4 pi r squared. Okay, where the surface area is dependent on the radius. But notice we just have a circumference. We're given the circumference. But do we know the circumference of a circle? It's 2 pi r. So since we have a circumference, instead of getting surface area in terms of the radius, let's solve for r by dividing both sides by 2 pi. And then plugging it in for r right there. And then we have our surface area as a function of circumference.